Yes, good morning to all of the participants. And I apologize that we will not talk in Italian language as it was indicated maybe in the title on the LinkedIn posts and so on. It was already outlined. We will do this in English. And our topic for today is managing chemical and microbiological risk in cosmetic manufacturing. So I think this is a very often discussed topic if it's coming to cleaning, and I would like to give you a brief overview of what we will talk about. So we will start with the, I would say, first question: why is a cleaning process of an equipment even needed? So why to clean a process equipment? This will be maybe an obvious question, but at the end, it will also lead to the next question of how clean is clean really? And I can tell you, I have been to a lot of sites. And if you ask this question, what does clean mean for you? How clean is clean? This is something what is different for different companies and even on different sites. This is why we want to raise this topic here and to give you a little bit of the attention of how you might rate how clean is. Also, we want to achieve today that you say at the end of the day, I know now my equipment is confidentially clean. So that means that you have a very good understanding what clean means and that the cleaning process you are approaching is delivering this result. So let's come to the first question. Why is a cleaning process of an equipment needed at all? That is really an obvious question because you might say, yeah, the goal is always to mitigate the risk of a contamination. So you want to have this kind of compliance that even the regulations tells you, the equipment should be cleaned after use to avoid cross contamination. Also, that avoids like recalls or even production shutdowns for a time because of the fact that you have not cleaned adequately. You might need a re-cleaning or something like that. Also, the reputation of your brand is in question if you are delivering products what are not of excellent quality. So if your customer is getting a product what is not having the best quality, they might not come back and they might think that your products are not the best ones in the market. So this is the kind of reputation you don't want to have. And also for that, you're trying to set up the cleaning and the hygiene measures to these high standards that you can make sure your products are safe and have the best quality. At the end of the day, it's also about profitability. So you want to avoid that you have product losses or even scrapping products due to some contaminations, so that a white lotion looks brownish, something like that. And what also is true and what we see a lot in the industry today is that even the kind of production schedule can be challenged if you do not get good cleaning results. Meaning, if your cleaning is not good at the first time, you need to do a re-cleaning. And the next shift wanted to maybe start the next production batch, but they have to do a re-cleaning of the system because it was not completely clean. So this is then really, going to your production schedule. So to recap, the compliance is a global regulatory expectation that your products should be not contaminated or adulterated. And even from the reputation point of view, if there is some product not of high quality or not in the quality what is expected to be, the social medias today are so quick, and then your consumer might get the impression that, these products are not good for me and they will not come back to buy it. Also, if there are recalls or findings of batches out of specification or with contamination, that might need to scrapping the products or even results in significant rework has to be done, or it is an economical damage, meaning also that all the raw materials have to be scrapped, and this is not a kind of nice situation for none of us. So here we would like to go a step further. What do the manufacturers are inspected by? And if you are delivering, for example, over-the-counter drugs to the North American market, you might be inspected by FDA auditors. And they are outlining that during an inspection, we often find deficiencies to cleaning. That means that visible residues are visible on cleaned equipments. So even maybe that sometimes personnel is not really following cleaning procedures completely. These kind of citations, so these kind of sentences have been said by the inspections. Also, if you are contract manufacturing, your brand owner or the brand owner of the brand you are producing is making an inspection. And here it's clear that we see often people say, yeah, you should follow 100% the GMP and also ISO standard norms. So an effective cleaning procedure is followed in lines of changeovers. That means if you have a product changeover from one product to the other, you have to make sure that the equipment is set it up for the next process in a way that you do not have any harm to get the next product not into the right condition. So these are the two main drivers if you get some inspections to your site, and even I would add here a third party, or meaning your own quality inspections, what you are doing. So these kind of three subjects might come up to say, why do I need to follow this cleanings? And if I look to the recalls, and I'm just using the FDA recalls now as a example because we do not have so much information in Europe, and here we do not have this strong regulation on some of the cosmetic products. But even here we can see that even this kind of contaminations of cosmetic products are often related to microbial contamination, so microorganisms in products. And this is why we set it up also here, this webinar, to really outline what is the difference between, yeah, it's looking good to me, it's visually clean, and what is maybe, beyond visual clean. Is there something else I should look at? And based on that, you can see the other reasons like unapproved color would be a classical carryover of product residues into the next product, or even that you find foreign material that is really seldom. But if you look what are the top FDA recalls in 2022, they were related to, for example, Bacillus cereus, what was seen in a dry compressed powder but applied to the eye. So that was really irritating the eyes. Or Burkholderia cepacia, a germ known for the possibility to build up biofilms in even water systems because they are tolerant to very low nutrition. So, and if you get something like that in the water system, you might get a product with products what are not really preserved in a very good way. And even this microorganism is resistant to a lot of antibiotics. So this is really a kind of worst case situation. Or what even was outlined that in some of the tattoo inks, they found a contamination of Clostridium. So that this was the root cause analysis was looking to the improperly cleaned containers. So these kind of reasons lead to the fact that it is outlined. Yeah, the cross contamination is often under control. We have still 10, 11% of this kind of unapproved materials, or that there are some skin irritations. So, but the most of the recalls in the cosmetics, what were seen, were related to microbiological contamination. And it must not be hurting only the user. We know also that some of the microbiological contamination can lead to, let's say, um, not homogeneous product anymore. So you will have phase separation of products, or you will have different odors. So the smell of the product, something like that can happen very fast with a microbiological contamination. Let's now come to the question how clean is really. And for that, I would like to invite Marcel to give us a little bit of a background and some stories of what he sees in his daily work at at cosmetic sites.
Yes, thank you, Thomas. Talking about clean, I think we want to set the base on different type of clean. So in the end, we see three types of clean. We start with the visual clean, so meaning that we see no visual presence of any product or any detergent what we could see. The second pillar is, are we completely free of residues? So the things that you cannot maybe see visually. And in the end, the third one, and like Thomas was mentioning already on the microorganisms, only microbiology, is that already gone? And regulations are talking about it, that it's not allowed, but it's not very strict in that way. And I think we want to touch all these three pillars to go into deep and to see also what are the risks and what can we do about it. So if we go to the next slide, we start to talk about visually clean. And I think for me, this is in my daily practice, when we go to customers, what Thomas was already saying, it's a very good discussion point, because it's also the start of every clean. So how can you judge that your cleaning is good enough? And like in the GMPs, the cosmetic GMP, we already say, okay, there must be a level of cleanliness and appearance to get rid of general visible dirt from a surface. So that's clear. But okay, how clean is clean? And that's what we're going to touch in that way. So what we said, the regulation is quite clear, but also not in the end. So because cleaning is eliminating generally visibly dirt, and you should clean and sanitize at appropriate intervals between batches. So what does that mean? I think that's something what you would have to find out based on the risk of the products that we make, and changeovers of raw materials or microbiology. But in the end, it is about cleaning. Also, the FDA, if you're making out over-the-counter drugs for the US, they say it must not contain a potential harmful substance, or it contains filth. So a little bit more general, but I think it's clear to say that everybody, even at home, how do you see if your washes is clean? You see that by looking at it, and am I visually clean? You're not looking, do I not have micros or something? Because you cannot see the micros in the end. So visually clean is something where we have a lot of discussions, especially when we have difficult to clean products that we know that are difficult to clean. So if you click one time more, Thomas, please. So the ones that we have a lot of discussions about are the high mineral and pigmented loaded products, typically like the waxy formulations. When you produce OTC, the drug actives or the titanium and zinc oxides that are very difficult to remove. And still, although everybody's pushing to nature products, silicones are still, I think maybe 50 to 70% of my work is to get rid of difficult to clean silicones, because in the end, all those products that you see here are not really water soluble, or even do not like water, low water contents, high pigmented, so you can also see the dirt, and that's sometimes even it shows the dirt when we go into colored products. It's not that it's difficult to clean, But okay, if you produce a product that should be quite easily to clean, but you don't see it quite good, and we're going to touch a little bit more in this webinar on how do you see that it's clean. But if you run a charcoal product afterwards and then the complete equipment is black, oh, maybe I'm not so clean in the end. But it's yeah, it's in this type of products very difficult sometimes, but okay, it's doable. We talked about difficult to clean, but also easy to clean. We see a lot of challenging coming up, and because like these easy to clean products are mainly very basic products that we use as shower gels or body creams for the shower and so on. But in the end, if you don't clean them properly at appropriate intervals with the correct products, even the smallest substances can be detached. And you see some examples of pipes, and pipes is of course difficult to monitor, but this is reality. And it's even that this type of residues are very difficult to remove in the end. But if you use proper intervals for cleaning, it should be good. And in this way, easy to clean. Why I have microbiology problems on easy to clean products? I'm cleaning, but are you cleaning? What is the visual result of your cleaning? Do you monitor that? Because the risk is low in the end, but okay, if something is not cleaned visually already, then the discussion starts. Visual residues on stainless steel. That's most of the equipment that we work on in the cosmetic industry are from stainless steel, with different grades, but in the end, that's already the challenge to see the differences in grades. But here you can see on the left some examples of residues filmed of a silicone or an oil on a mixer. So you see there's droplets showing up. It's transparent. It should be nice. It's clean. I don't see any color, but is it clean? And on the right hand side, it's more obvious because then you got iron oxides from a suspension. So mostly on water level or production level, there you can see a lot of the time those difficult to remove pigmented products. What's this? Is it the brown vessel? No, this is what we typically see if we do a lot of sanitization by steam. So then your stainless steel can be affected by rouging, and this type of rouging even you cannot wipe it away. Sometimes you can, but okay, is this clean? I don't know. It's visually not the same as a shiny stainless steel vessel, and that's the discussion that you have to get and to see, okay, which type of visual residues we have. And if you want to go into a better state, the best advice is always to come back to base. So if you produce for many years on this equipment, first task is, like the GMP is also setting, you have to remove everything, but okay, you need to start with a good basis that you know, okay, from this basis, my cleaning is every time the same. So left again the rouging, difficult to judge maybe to see residues, but if you do some passivation maybe to get rid of the rouging, you see a different tank again. And I think it's better from the right hand side, from that base situation, to judge if your cleaning is perfect or not. Like every testing, also visual inspection needs a test method containing the 4 pillars. So you have instrumentation, sample preparation, calibration, and standards. And how does that work in the end? Instrumentation, that's how we. So the operator, as a testing device, must be capable of judging the visual inspection. In the end, the sample, it's the equipment condition, what we just touched about. So what's my base state? The calibration is, okay, which type of light do we have? How does that look like? And in the end, if I got a standard to compare against, then it's something what you have, your visual inspection could be successful. Going to touch a little bit more on the different pillars. Because instrumentation, we are all human, so everybody sees different. Thomas has glasses, I have contacts, but I also have glasses to read. So it's like, okay, how are we there? And especially in cleaning validation, where Thomas is going to be touched a little bit more against also, you see sometimes that and not the operator is doing the qualification of that cleaning validation, but a trained QA supervisor or QC supervisor is doing that. So are my eyes, are my my color seeing, for instance, I don't see all the colors there to the right because I'm colorblind, and most people, most men are, more men are colorblind than the women, but it's typically that you have to really see, okay, this is, are you suitable and trained to do visual inspection?
Maybe if I just step in here shortly, just
Yeah.
to give you an idea, in the pharmaceutical industry, they already have now from the European Medicine Agency an outline that a periodic eyesight testing should be done for people who are making visual clean assumptions for equipments. So they have a question and answer document what outlines if somebody is checking on visual clean in an equipment, he should get a periodic eyesight testing. The periodic frequency is not named, but we have now customers really going into details and saying, okay, every 2 years, my operators doing these kind of activities have to demonstrate that they can still see in a good way. So just as an add-on to that.
Yeah, thanks, Thomas. And I think that's also the importance showing that visual inspection is has to be taken seriously, and it's very important for how clean your equipment is and what risks are there with that. Because the first step of this equipment is get it to visual clean. The best way always is to judge a vessel if it's clean, if it's when it's wet, because then most of the time it's clean visually. But that's not the idea, of course. You have to judge it on the state that you want it to be, where you can see which type of residues that are giving you the most risk are giving you the results. So typically you judge a vessel when it's dry, because then you see all the residues that come up. So it should be like, oh, it's clean. If you look into the vessel during your cleaning or during a rinsing, oh, you see it's clean. But if you see it dried up, then you see, oh, what has happened? But that's the drying up phase. On the other hand, if you have like silicones on the right hand side, you see the droplets. Then you can maybe say, okay, when I have oily residues or silicones, maybe I have to do a little bit of inspection before the end of the dry, because then I can see if I see the droplets, that means the water is not spraying out, so I got hydrophobic residues on my vessel. It's maybe best to judge it at that time. The calibration part, do I have the right correct lighting? Sometimes we have an old vessel, maybe even not having a lamp. Sometimes we have a lamp on the left side and my difficult to clean areas are on the right hand side. is my bulb good enough? Do I need UV light? Which angle? With light source? A lot of things can give you different type of results in the end, and that's something what we also see in pharmaceutical industry sometimes, even, but it could be in cosmetic also with powder. Sometimes you have to, it looks like it's clean, but if you take light and look over the surface, yeah, then the dirt shows up. Even I at home have a vacuumer with the lighting now that I can see my dirt, and that's more or less the same. So it looks like that your floor is clean, but if you have another lighting situation, then you see, okay, I still got dirt there. And the standards. So it's very important from situation to situation to say, okay, this is a situation that we are finding acceptable, looking at all the requirements and risks. So even if we see maybe some rouging or products from the past that we cannot remove anymore, this is past. But you need to set that standard. What is visually clean in that way? So left-hand side pass, and maybe give a right-hand side, this is not passing because I see dried up residues of silicones, or I have a water break free, not water break free surface before drying. Be very specific on the equipment and the soil type to say, okay, this is passing visually clean and this is not passing visually clean. And now,
Okay.
up to you again, Thomas. Thank you.
Yeah, and just maybe for the information of the audience, the picture you were showing here with these water droplets on the surface 3 slides before were really rated by the customer, where we took the pictures, as visually clean, because the water you could see, these water droplets, were purified water, so not giving any water hardness stains or something like that. And they were not aware that they even have a kind of residue on the surface. This is why we also want to talk about residually clean. So you can often identify these kind of situations that you say, is really the water shading down in a nice way on my stainless steel equipment, or do I see a lot of accumulation of water droplets that is standing for a really high amount, or not high amount, but there is an amount of hydrophobic substance then on the surface. So we really want to outline that these kind of residues might not be visible, and it has happened to me that I had even an inspection where it was outlined, this is a visual clean surface, and it was like with a unique coating film of an opacifier inside of the equipment. And this is exactly what just was outlined by Marcel, that this kind of situation can happen, that oh, I'm using this to prepare specific products, and they tend to react with my stainless steel, or I get some residues what are not having any impact on my next production. So this is when I have to really calibrate the people. What does it mean? And also the pictures we have seen with high hot water treatment or steam treatment, this coloration could be also effect that you say, yeah, that is a kind of identification for me. This is even visual clean, and I know that this has happened, but yeah, this kind of things is what I do. And now we are going a step ahead and say, now we want to see, are there residues on the surface? And yeah, what kind of residues would you tolerate? Just to take an example from the GMP in pharmaceutical production, they say, yeah, you should use health-based exposure limits to set limits. And this kind of limits are there to establish also removal of cleaning agents. This is not seen as strict in the cosmetic industry, but we see more and more customers are going into this direction, that they say, oh, what kind of limit settings is done? Are there different ways in different industries? And I know, for example, also from the biotech industry and pharma industry, that they have different ways. So a biotech will look at maybe, yeah, is a protein still effective, or is it denaturated by the cleaning process? That is for them maybe already enough to say, then I don't care about it anymore. But for us, this is really something where we could ask, yeah, are residuals showing up, and what would be my acceptable limit? I need to identify it. We heard about the visual inspection. So if I have a red film in a equipment after producing a makeup, then for sure I can see it with the analytical method of the naked eye, so to say, in the visual inspection. But there are also now methodologies outlined in different publications where they say, yeah, if you want to analyze on residues, you should align your test method with the risk aligned. So what does that mean? For example, you see here on the right hand side that a visual inspection is done for a lot of products where you see not a very high risk of a, for example, consumer health, or even for product quality defects if something happens. Then you would maybe just use the visual inspection. A precondition for that is as well that you can inspect all the parts, all the, yeah, product contact surfaces, to make this visual inspection and say, yeah, this is my result I get. If it's coming then to analytical results, because we have a lot of customers saying, I cannot inspect all of the equipment in total. I need to do something to see if in the circulation line there's still some leftovers, or is there something on certain surfaces like these wipers made of Teflon. So what kind of analytical method should I use? And very often for cleaning validation, we now recommend to do things like, yeah, just to process what, yeah, makes analytics on some parameters like total organic carbon analysis or conductivity, because it's easy to do, and you have even a very good outline if product residues are present, what could be waxy oily substances also having a total organic carbon residue impact, or even the detergent having surfactants also containing TOC. So you will set a limit based on a certain level, threshold level, and say this is okay for me. Only when you have high risk situations, and this is where you maybe are using these kind of, yeah, eye products, or if you're producing some things for inhalants, something like that, so over the counter drugs, for example, to, yeah, push in seawater into the nose or something like that, there you might be a little bit more careful and say, I want to go to more specific analytical methods like HPLC or something like that. What does the FDA tell us? They know that the risk is there because they say there is a big variation of equipment and products produced in each site making personal care products. So this is why they say we will not give a fixed guidance on how to do things. We want to make this on the manufacturer's knowledge and of the materials involved. And what we see more and more now is, for example, that if you go into the direction of using more ecological raw materials, you might get even troubles with impurities, or what the next topic is also with microbiological contamination, what you did not find before because you were using materials coming from synthetic sources. So these kind of discussions is what is even aware to the authorities, and that they outline, yeah, you should take this into account if you talk about how clean is clean.
Yeah, and Thomas, to add to that,
Yeah,
the detergent, of course, is often the topic that we are involved with. But here, the FDA also clearly says it's the industry knowledge. So it's also that you have to have the knowledge of your own portfolio of raw materials. Also, what is the risky part of that one? Because sometimes we only focus on the detergent, and in the end, yeah, you have to get the complete picture. That's, I think, very important to mention that.
exactly. And this is why a lot of people are asking us, how do residues of cleaning agents look like? Because, yeah, they
Yeah,
know, oh, the iron oxide red is looking like what kind of reddish film on the surface. But if I have a detergent, can I see that? And this is why we made some spiking studies. You can see pictures here where we outline even different detergents may have a different appearance on a surface. And on the top picture, you have a concentration what is around 10 microgram per centimeter square. This is a concentration where even from the literature you would say, yeah, this is a concentration you can see fairly good with your eyes on a stainless steel surface. And you can even see some of them are looking oily. The one of on the left on the right hand side is completely looking like, yeah, is there a white powder or something? Some spots are white and having crystals on it. So that is really an appearance. If this concentration is there, you can even say different detergents look differently, but this concentration is something what would not look visually clean. On the other hand, if you are having a lower concentration, this 1 microgram level we applied here, you can just see imprints. And these are the same products as in the picture above, but it shows just, oh yeah, there's a droplet dried onto the surface, and then it's showing me something, but I cannot really see if it's a mineralic or if it's something like oily. It's just an imprint. And this is how we say, yeah, detergent residues are very often like that. You can see something, and they are not like your product residues. So if you have titanium dioxide as a pigment, it will be a white powder and not like a spot, something like that. And this awareness to the people making visual clean inspections would be needed to have, that they say, yeah, to what kind of residue do I look for? At the end of the day, we are also asked what is the kind of limits I can set. And in the past, there were often calculations done, what were called maximum allowable carryover, the so-called MACO calculation. That is based on LD50 values, so toxicological data. These days, we see really the trend also coming from the pharma industry to use like maximum safe carryovers, because yeah, nobody allowed you to use this maximum allowable carryover. This is why the terminology changed now into effect that they say it's a maximum safe carryover, and the basis for that should be a calculation based on a permitted daily exposure of the substances you are producing and you are processing. The same can be true also for the detergent carryover. And then based on this maximum safe carryover, you have to set some cleaning limits. And even if they are like, yeah, 10 ppm, what you have had before, or if you want to go to more strict levels or to, yeah, even other limits like these safe carryover limits, that would be a discussion with your quality units. At the end of the day, these
Thomas,
were all,
Thomas,
yeah.
Thomas,
Sorry.
maybe just want to add, because I think we are discussing quite high level on risks and so on. But I think in general, do we need to be afraid of the risk of getting detergent over from one batch to the other batch? I think in reality, what I see in most of my customers, if if the process is good and you have a proper rinse and you use the product that are designed for the cosmetic industry to remove the soils, but it's also easy to rinse off, and that's something that have to be aware of, that you need to have products that are designed for this industry, that they are easy to rinse off and not consisting of materials that are difficult to rinse off. Then if you're using that materials, and with that, I think typically we do not see people that are struggling to get to that levels that we need to have. I think that's some remarks that we have over there. But okay,
Yeah.
rinsing is with the right water quality is of course needed. But do we see problems? Yeah, setting it up, but the results is quite good always, I think.
Exactly, exactly. If you take the detergents designed for this industry, you're absolutely right. And what I see even a different move at the moment, that people look more careful to residues if they use detergents, as if they say, oh, I have easy to clean products and I will just use the water flush.
Yeah.
Because then they are even more intensively looking if they are using detergents to, yeah, what does visually clean mean? And that the examples you have described before, sometimes they tolerate, oh yeah, there's a slight residue inside, but we know the next product will contain the same ingredients. We do not want to over clean everything, so we want to be pragmatic. And if they use detergents, they look more closely, and I think that is the best solution. And if you use the adequate detergents for the cosmetic industry, you can have a complete rinse of the system, and you get even the ideas of what analytical methods you can take to assure that no carryover of detergents is there.
Yeah.
And I think analytical method is a very good yeah, hint, because not only residues can be tracked, and we have seen that microbiology can be really a topic, because a lot of these recalls from the FDA have been based on microbiological contamination. And so even here, we do not want to have any contamination, and even any injuries or any health concerns to the consumers based on microbiological contamination. So what do we see? We see that, yeah, we should control the bioburden on the equipment. I see often that quick methods like these kind of ATP swaps are used to get a general idea of how is the status of the equipment. I think for the daily routine, this is a very good indication to say, where am I? So I have a good idea on, oh, this is the standard level I have on the ATP measurement, because you cannot decide if it's a living organism or if it's a dead microorganism on the surface, but at least it gives you a bioburden level you have. You do not have to make these kind of contact plate analysis and so on anytime, but it's also here depending on the product you are manufacturing. So this is really something what we want to emphasize. Always when you are talking about your needs of doing hygienic measures, it should always be looked at the product you produce and what is the risk for your consumer, for the consumer of the product, and even for the product quality of the next product. At the end of the day, even here the FDA says something that there should not be any poisonous or deleterious substances on your surfaces, and even the microbiological contamination is seen, and this is the last two lines here on this sentences, that poisonous or deleterious substances may include also microbiological contamination, because it can harm the people. So you should have an idea if your products are sensitive for microbiologics, and even what I outlined before, if you go to use more organic materials, do they have a higher pressure on germ contents? Are your levels what you have tolerated in the past still okay, or do you have to go for a more strict approach now, because we see that organic production maybe require more disinfection due to the materials involved. So these kind of considerations is what we want to give you on the way here and with this seminar. I've had one situation where a customer even outlined he thinks that all this cleaning using cleaning and sanitization agents are over the top for him. He does not see a need for that, and he was doing microbiological control on a frequent basis. And you can see here that beginning of 2022 they decided last year to stop using of cleaning and sanitizing agents. They were switching to rinse with water, and even then to have hot water sanitization. And what happens is really that we could see in the monitoring data on the equipment that they increase over the time. And this is really a classical situation if no cleaning and sanitization is taken place on a frequent base, that we see that often there is an increase first of all, and then you might even get to a situation where you get to a biofilm on these equipments. And this is of course what we think is a really a critical investigation to be made, and then also to remove that from surfaces is really hard. So this kind of monitoring data then clearly shows that it can help you to have the microbiology better under control using detergents what are made for the cosmetic industry and also sanitizations. I make now the terminology of sanitization, because I think it's important to understand that there is a definition for disinfection. So people sometimes say to us, yeah, I'm doing a hot water disinfection. This is not existing in Europe. So the disinfection is always a log 5 reduction, where you know that this, yeah, action what you're doing, and most of the time it's using chemistries to reduce the microorganism by 5 logarithmic scales. So this kind of information is what we have, because most of the time if you use like hot water, then you might do a sanitization. That is a 3 to 5 log reduction, and that's the reduction of the bacteria population. And we took here on the left hand side the different standards, so ISO standard, USP, or guidance on the BPR. What do they say about these kind of different actions to reduce microorganisms? And for sure, the sterilization is the best one you can do. Very often disinfection is just enough, but what we see often is that still sanitization only is done. So that this kind of action you are doing should be classified, and you should have be clear understanding, what does this control on microorganisms do for me? Is it really a disinfection of a proven log 5 reduction with a detergent where I know a 2% solution will kill, for example, viruses? Or is it something where I just say, well, 80 degrees at 20 minutes will just do something on the reduction of microbiology in my system? So this is the last point I wanted to give on the way, because if you get something like a biofilm, then you will have it always in a place where you have not a visibility. So it's very seldom that we find biofilm contaminations in, for example, contact plates on product surfaces. Very often if it's in rinse samples that there are some findings, and they are, yeah, coming up spontaneously. So you get a finding, you think, oh, I have to retest it. There was maybe a, yeah, sampling error. Nothing is happening anymore with the repeated analysis. Oh God, yeah, now we are good. And then, yeah, next monitoring data showed there's something again. Oh, I have to repeat it again to, yeah, make the sampling. And then you might really see, oh, there is a biofilm formation in the system. I get from time to time positive readings, and they are more frequent over the time. And then it's time to really make a basic cleanup of the system, and really a biofilm reduction cleaning. This can be really intensive, and we want to avoid that in any case.
I
So with
think,
all of,
and
yeah,
just one remark there, and a lot of times when we are on site, we see when we have a biofilm, but is it then cause of the sanitization or disinfection method? But for me, it's always like, I always find, oh, you can find different problems in disinfection and steam and water. Do I have the right temperatures, or do I have contact? But most of the time, what I see is, are we getting to visual clean already with my cleaning? Is my cleaning successful? Because if you clean properly, there is no way that a biofilm can already be there normally. So it's to come back to visually clean there already. I think there is for me always most of the cases already the basis of the microbiology problem.
exactly. Thank you for this
Yeah.
insight. And I just want to close this, yeah, here with yeah, 2 case studies to talk about confidentially clean. And these were 2 case studies we did really with the focus on, yeah, is it really visually clean? Is it also residually clean? And also the microbiologically cleanliness is given. And we were doing this really by things that we say, yeah, we want to do this to enhance the protection of the brand you are selling to the consumers. We want to avoid economical damages due to cleanings, so maybe even minimize scraping and so on and shutdowns, and also minimize the recleaning occurrency, because you want to have your production scheduled, and you want to know when you produce what kind of batch. So looking into that, there was a challenge that there was, yeah, I would say a big variation in a manual cleaning operation. So there were, and at this customer, we still saw residues of sunscreen active ingredients on the surface on small parts. What did we do? We had to really find an effective chemistry for this manual cleaning application. And we were even going to do this kind of cleaning validation training with the people. So how to clean the equipment in the proper way, how to rinse it in most effective way, and then to discuss with the operators on what maybe has gone wrong in the past to avoid these kind of mistakes. So, and a challenge always is the manual cleaning operation, because it's, yeah, varying from operator to operator or even from Monday to Friday. So the impact is then to make this successful cleaning and validation, to always be on top of the list and say, with these improved SOP validated, we implemented now a manual cleaning procedure, what is much better in for this application and customer. Next situation is that there was a hard to clean soil. So there was an oil-based pigmented cosmetic premix. And it was really so that they run different CIP cycles to get to visually clean. And it's outlined here, often 2 to 3 cycles, most of the time 3 cycles. So what to do? Also here, we need to first of all identify the best cleaning agent. So we perform cleaning process development studies in our lab. And then we are there to even implement these new processes on site. So then our team of technical consultants and even our teams in the different countries are there, and in Italy, for example, to help you out and say, if there should be an on-site implementation, we want to be with you and we want to assist you how to use this product. Can I flush it in hot or cold? Do I need to circulate during heating? These kind of things is what we can help you to successfully make this new process under control in your site. With that, you can decrease really the cleaning downtimes, and you get to a state what I hear often as a topic named is right first time cleaning, or cleaning right first time. And this is our achievement, I think, what we want to give to the cosmetic industry, to say, yeah, if you get the right first time cleaning, you can save a lot of downtime of the equipment where re-cleaning is required today, and you gain a lot of productivity, so you can produce a lot of more batches over the year.